Hello, let's take a look at this question, 5.2 A2 part B. Now, once the switch is opened, what will happen to these quantities? So let's take a look at the current passing through bulb 2, which is this current over here. We can solve this quite easily if we look at the resistance of this parallel branch. Now, we all know the premise. As we add more components in parallel, we lower the effective resistance of the parallel branch, right? So once we open this switch, the parallel branch will disappear. It will become bulbs 4 and 5 will be connected in series with bulb 2. So this means the opening of the switch. If I open the switch, I will increase the resistance of this branch over here. This opening of switch that results in an increase in the resistance will then lead to a decrease in the current along this path. So this is the reason why the current through bulb 2 will decrease. Now, it follows therefore from this decrease in current that the potential difference or the voltage across bulb 2 also decrease. Just use Ohm's law. Okay, or alternatively, since we know about the resistance of the originally parallel branch has now decreased, we can also use PD equation to get the same conclusion. The power dissipated and the brightness will therefore all decrease just by using any of the power equations, P equals IV, I squared R, or P squared over R. Now, moving on to the next part, calculate the current passing through bulb 4. In the earlier part of this question, we are given the power rating of these bulbs. So whenever we are given the power rating of the bulbs, we should always find the resistance of the bulb. So let's start by finding the resistance of the bulb by using the power rating values given to us. And we should get 120 square divided by 60 watts. This should be 240 ohm. This resistance of the bulb wouldn't change no matter what voltage we apply across it. Of course, this is assuming that the heating effect is negligible in the bulb. Now, to find the current passing through bulb 4, we note that the current passing through bulb 4 is the same current that passes through bulb 5 and is the same as the current that is passing through bulb 2, because 2, 4 and 5 is now in series with the switch being open. So let's just let this current to be just I say 245. Alright, just a label. Now, to find this current, we can use Ohm's law on these 3 bulbs in series. This means that we must use the voltage across the 3 bulbs in series divided by the total resistance of the 3 bulbs. Okay, now these 3 bulbs 2, 4 and 5, they are in series and they are one parallel branch in parallel with bulb 1 connected to the battery in parallel also. So this means that we can easily use the EMF, which is 120 volts across the 3 bulbs combined resistance. And if we calculate this, we will get 0.167 amperes. Now for the last part, to get the power dissipated, we can use I squared R for the power equation, and borrowing the answer from the earlier part and plugging in the resistance of the bulb, this is how we can obtain 6.67 watts.